Chapter 3, Section 2.2, Part 1 video. In this section, we'll look at some basic functions that we need to make sure we are aware of. Okay. All right. So the first couple of things are really, I guess you could type it in your calculator if you want to, but they're more order of operations, looking at different things, just kind of evaluating different things. So that would be -1 times the absolute value of -14, and you should understand that anytime you take the absolute value of anything, it returns a positive. The reason why it returns a positive is that is the distance from that point back to 0. That's really what absolute value does. So that'd be -1 times 14, which would be -14. Okay, this one is this. Okay. Anytime there's a negative sitting outside, you got to always make sure that you understand that there's a 1 there, right? Close that parentheses. So that's a -1, so that gives you a 14. Okay, basic mathematics on analyzing. All right, so we're going to do a couple more. So 4 minus 7 times 1 minus 9 is -8, right? So I'm putting that in the absolute values. So here's my absolute value bars here. So that's 4 minus 7 times absolute value of -8 is +8. So we got 4 minus 56, ladies and gentlemen, that is -52. So basic little order of operation stuff. Let's do another one. The absolute value of -5 is nothing more than 5 minus absolute value of -6 is 6. So 5 minus 6 is -1. Absolute value is 1. So they're just kind of daisy chaining some things together. These are your absolute values here, right? There and there. Okay, now on this one, what we're going to do is I'm going to use the calculator to do some stuff to make life a little bit easier. We're looking at x cubed, right? So clear that out, go to y equals, clear, come back up. I'm going to hit x. Now if I want cube, I have to hit math and go down to number 3, and it'll put x cubed up there. Okay, so I just want to hit graph, and my graph doesn't necessarily show like what the other one does because they've got some crazy limits in there. But I want to take it back to zoom 6, which puts it at a -10 to +10 on both axes. Okay, zoom 6 does that. So if you look, this kind of matches what we're seeing on our graph, right, to some extent. Here's the questions that are asking me, or that they wanted to ask me, so we can evaluate some things. This is, they want you to estimate the value of 1.4 cubed, right? So that's just regular. I mean, if I go to second graph, I can kind of delete. That's an input, right? It's an input. So the x value is 1.4, y value is what, right? So I'm going right here. I'm going to type in 1.4, hit enter, and I got 2.744, right? No big deal. So 2.744. Now find all the numbers whose cubes are -16. So this is x equals when y is -16. So guys, we're going to draw, because they gave us an output, we're going to draw a horizontal line at -16. So we'll go right here, and we're going to hit -16, and we're going to come up to our window. Because we got a line that's going to be at -16, we need to make sure that we can see that. So we're going to put -20 right there, right, in the y min. Hit graph. All right, so we know it intersects right there, so we're going to second trace. We're going to go to number 5. We're going to move that thing down. There you go. And hit enter, enter, enter. Ladies and gentlemen, -2.52. Okay, -2.52. Let me write that a little bit better. All right, now same thing. Find the numbers, find the solution. That's the same thing. So x equals what when y equals 6? So guys, we're going to do this again. Come back in here. We go to y. We instead of negative 16, we're putting 6, right? Let me hit delete, delete. Really just should have hit clear and just put 6 in there. We hit graph. Now we want to intersect up here. So second trace 5. Gonna move that thing up. Okay. Enter, enter, enter. That's 1.817. All right. Now, on this one, it's just the way it's written. So they want you to take the cube root of 24, right? I guess you could do that on the calculator. We take the cube root of 24. I'll show you how to do that. We'll just clear here. We'll hop out of here. So we're going to hit math, and that's number 4. And we're going to type in 24 and just hit enter, which is 2.884. Okay. 2.884. Now, if you want to look at it in terms of calculator, x equals what when y equals 24? The reason being is this is saying like this, right? And if you solve it algebraically, they want to find what x is because they gave you an output. Okay, so that's a bunch of math that you may or may not want to know, but it's there. All right, so okay, on this one, they're giving us fx is x squared and g of x is x cubed. We're going to use the graph and to find all solutions when they're equal. That means when they intersect. Okay, so x squared and x cubed. So here we go. Make it clear. All right, so I'm going to type in, clear. X squared, and then x, go to math, number 3. Okay, or I could just hit the caret top there and put 3. Caret top 3 would have been the same thing. Now, I'm just going to hit graph. Oh my. Now, there's nowhere else that these are touching, so I really want to concentrate on this area. So what I'm going to do is I'm going to take my my windows, and I'm going to say -1, 2, 3. Hit graph. All right, so let me hit that again. Let me do -3 and then hit graph. There we go. We should know that they're going to hit intersect right at 0, 0. But let's go second trace 5. And I'm just going to move it off of it, right? Just for a second. Enter, enter, enter. Well, they're telling me that they're intersecting at 1, 1, right? X is 1, right? So, okay. So 1, and I bet you since that's at 1, we better go, let's go back over here and let's go second trace 5. Let's move this baby over here. There we go. Let's do this. Enter, enter, enter. And it's at, just +1. Why wouldn't it be at -1, 2? Nope, just there. Let's look at a table. Let's go window. Sorry, second window. Auto enter. Second there. 0, 0, and 1, 1. So you just got to be careful on that one. So I knew it was at 0, 0, but it's hitting at 1, 1, 2. So 0, 0, and 1, 1, or is where it. Okay. So if we know that, these are my x values. They go in here, right? And what interval is f of x squared greater, outputs, right, than x cubed. So let's go look at our graphs. Let's go look at our graphs. Well, it's going to be greater from negative infinity to 0. Well, let's look at this. Let's go second table set, and let's go 0.2, and let's start that baby at negative 1. Let's do 0.25. Okay, and then we're just going to hit the table, and we're going to see. Let's see, x squared is the y, right? And y1's the blue. So let's look at this. So the blue one. So let's look at the equation. We want to know where's the blue greater than the red. Blue's greater than red. We've seen all the way up there. Then so blue is greater all the way from negative infinity all the way up to 1, right? So it would be INF, comma 1 bracket. Okay, so, and I looked at my table. That's kind of what I done, folks. And I looked at my graph, limit graph, and we found those intersecting points. And sometimes, it found it 1 here, right there. But I know that it ought to intersect at 0, 0 as well. So I went second table to kind of give me some more visibility on it. And I stepped about 0.25 so I can really see some resolution on my numbers. But when my outputs are the same, that's where they're going to intersect, okay? So just kind of work with that, kind of play around with that on this particular example, and you should be okay. All right, so I think that's enough for section. Let's see. 1. Yeah, that's enough for you to for section 2.2 part 1's video. So